Greetings. Welcome to our 11th episode of the FGI podcast series. My name is Tim Stark, and I'm a professor of civil engineering at the University of Illinois at Urbana-Champaign.
And hello, everyone. This is Jen Miller, and I'm the coordinator of the Fabricated Geomembrane Institute, or the FGI.
On today's episode, we're going to focus on the last webinar titled Understanding Leak Location Surveys for Owners and Inspectors, given by Matt Kemnitz of Leak Location Services, Inc. in San Antonio, Texas. So good morning, Matt. You recently recorded a webinar with us, and I didn't get to cover all of the questions that we received during your webinar, and I received some additional questions after your webinar. So I'd like to go through these questions with you.
Okay.
First,
happy to do it.
Thank you, and thanks for a great webinar presentation. First question is, how do you price a project before you arrive at the site? Because you usually determine the measurement or density of your measurements after you arrive on site.
That's a good question. We typically have a lot of conversations with the client before we get to the site. And what that does is it allows us to fully understand what we can expect when we get there. So we're going to price it based on how we think we can test this and at what kind of spacing. But at the end of the day, when you're talking about a 5-foot spacing and a 10-foot spacing, you're talking about double the data. So if we priced it at a 10-foot and it ended up working out, it's going to take us twice as long, and therefore we would be way out of budget. So we're going to have to budget it based on the lowest spacing that we think is doable.
Okay. Next question is, could you provide some more information on when it is too late in the construction season, i.e. too cold, in states like Minnesota, North Dakota, to conduct a leak location survey?
So what we do before we come out, we will have somebody actually on site go to the cell and make sure the ground is not frozen. And the best way for a soil survey to tell that the ground is not frozen is if you just simply dig down the cover material, and if it's coming up in clumps or there's a frozen layer in there, then it's not testable. But if you're able to dig it and it does not go into clumps, it's okay. With any of the water surveys, if the water's not frozen, then it's testable.
Okay, sounds good. Can you please address the practicalities with respect to the differences between ASTM D7007 and ASTM D8265 in terms of the speed of construction and real-time repairs of leaks?
Sure. This is a good question, and it's one that we get a lot. 7007 has been around for I think at least 12 years. 8265 is about a year old. And so those two are very similar in many ways and different in many ways as well. For the speed of construction, that's up to the contractor who's building the site. For as far as 7007, the survey is not in the way of the construction. It can go on as we're testing, so it doesn't slow it down. I can't speak for 8265 if it can be done the same way or if they have to map the whole site at the same time. For 8265, it's basically wanting the cell to be mapped and showing the data a specific way. That's the main difference. 7007 allows for mapping as well as a graphical representation, so you could do it either way. So in my mind, if you're going to have somebody come out and do a test, you want them to test it the way that they feel most comfortable with, so they can give you the best results. And you don't want to force on them to do it and show it a graphical way that is not something they're used to doing, especially if they've been doing it for over 20 years. The repairs are found same day with 7007. So as soon as they're located, they're dug up, they're exposed, and they can even be repaired that same day. So there's no delay on 7007. On 8265, I believe most of the leaks are found at once the whole survey site is tested, all the leaks are marked, and then they go back one by one and expose the leaks. As we know from the webinar yesterday, that can be a problem because each one of those that stays in there can conduct current and pull them away from other leaks. Those are the main differences that I can cover right now.
Okay, thanks, Matt. Next, I have two questions related to a landfill bottom liner system in which we have different combinations of a composite liner system, that being a geomembrane and a low hydraulic conductivity soil of some kind. So, first question, if there is a encapsulated GCL, and that could be geomembrane, GCL, geomembrane, or it could be a geomembrane backed GCL with an overlying geomembrane, either one of those flavors, can the top geomembrane holes or damage be found by the bare liner method or the soil survey method or any method?
Okay. The quick answer is yes, they can be in both of those situations you just described. The GCL does conduct current. It's how you attach to the GCL to energize it so you can find the leaks on the primary. The encapsulated GCL works. There's multiple projects that can be shown in case studies to where they have been found. The GCL conducts enough to find the leaks, and not just enough, actually very well, especially when it's encapsulated. And then the other product where it's attached to the liner itself, that could probably be a little bit better situation because that GCL is in intimate contact with that primary liner. So if there is a wrinkle on that primary liner, it won't matter because that GCL follows the path of the wrinkle, and so the leak will be detected that way as well.
Okay. Second part of that question is, let's make the composite liner system a thickness of low hydraulic conductivity soil liner. So some states allow part of that to be replaced with a GCL. So let's say 5 feet, and then you replace 2 feet with a GCL on top of it. So you'd have 3 feet of low hydraulic conductivity soil, a GCL, and then you would have a geomembrane placed on top of it. Can that geomembrane be surveyed for holes and damage by the bare liner or soil survey methods?
Yes, it can. You have to energize underneath that liner that you're testing the correct way. And this all comes with communication before the job is set up and designed to make sure you can energize it. And once that's done, it can be tested multiple different ways.
Okay. Next question is, can a copper wire be used to perform a test of the primary geomembrane when the only item between the primary and second geomembranes is a drainage composite or a geocomposite?
Okay, this is an interesting question. We have actually tested a site like this before a few times. We don't recommend it and we don't prefer it because the geotextile between the liners, it's not conductive and there's no water in there. So the only thing that is conductive is your copper wire. But unless that copper wire is lined up exactly where a leak is, it's going to be hard to find. However, and I hate to almost say it, but we have found leaks because there was enough moisture in that fabric that took the current coming from the copper wire through that moisture in the fabric and into the leak. I have to say we were pretty shocked that it found it, but it can work. However, definitely don't recommend that. I would put a GCL or some kind of a sand layer in there, something conductive with the copper wire, and you'll probably find a lot more.
Okay. We had a couple questions related to double geomembrane liner systems after the webinar, and we've got some more about testing the secondary geomembrane and the primary geomembrane. So if you have to test each of those separately, because if you test only the primary, you won't find the hole in the secondary. So could you go back through and sort of lay out why that's the case?
So the liner, the geomembrane that's being tested, you have to be able to be above that liner with the cover material that's on it, or directly on top of it in a bare liner survey. In this case, when the primary is on top of the secondary, there's no physical way to get in that interstitial space and take measurements, so you can't test the secondary. The best way to do it, and the process would be for the secondary to go down. As it's going down, have it tested. Bare liner, soil survey, depending on how it's layered. Test it right there. And as you finish the secondary and you're moving along, contractor can come back over areas you've just checked off as good, and he can start laying down the primary. That way, when the secondary liner is completely finished, the next day the primary is finished, and you go back over and you start again and test the primary. So there's no delay in the construction process if you can work it together with the builder at the same time.
That's great. Great. Thanks. Okay. Next one is about heap leach pads. And I know after the webinar, you said usually the thickness that you can test through is about 4 or 5 feet, but this is an interesting question. Let's say we have a heap leach pad, say for a gold facility, and the heap leach pad is more than 100 meters high. and there's some leakage. Obviously, the gold solution and or cyanide is leaking. Could they perform a leak detection survey on the liner system below the heap leach pad?
This is a tall order. You definitely could. It's very rare, but it is doable. There was a situation that we found ourselves in with a client with about that much cover, and just taking the data on the surface, you're not going to be able to see what's going on by the liner. So the fix was we would drill holes through the cover material and get within 2 to 3 feet of the liner. And we would drop our equipment down that drilled hole and take readings on a grid pattern. It took some time, and it was a long process, but all the data was good because we were close enough to the liner. We found leaks, and it fixed their problem, which is great, because we don't want to just say all we do is find leaks. We want to help the clients find the solutions to their problems. This client unfortunately spent over $2 million looking for this leak before they contacted us. I wish we could have charged them that, but we did not. But at the end of the day, the problem was solved, the leaks were found, and everybody was happy. So it is doable. It is tough.
Okay, great. Well, Matt, we really appreciate you taking the time, not only yesterday to present that excellent webinar, but also today to answer all of these follow-up questions in this podcast form. So Tim and I are so grateful for you. Is there anything else that you'd like to add about your webinar yesterday, the questions today, leak location surveys in general? I'll give you the final word.
I'd just like to add, leak location surveys, as I mentioned in the webinar, they're nothing new. They've been around for almost 30 years. And they go way back, and there's a history, and I think that would be a good paper to write someday. Darren Lane, who founded Leak Location Services Incorporated, worked with the EPA, did a lot of stuff, a lot of groundwork for how all this came to be. And so I think it's really great that here we are 30 years later, it's still going. We're learning new stuff. We're finding ways to make it more accurate, more efficient. And so I'm just excited to see how this turns out in years to come.
Great, Matt. And so for the listeners, if you have any other questions or would like additional information, please email me at fabricatedgeomembrane@gmail.com or visit the FGI website at fabricatedgeomembrane.com. So we will wrap up with our taglines. Mine is, quality installed faster when you factory fabricate first.
And I will end with, may all your geomembranes be factory fabricated. Thanks, and see you guys next time.
See ya. Bye.
Thank you so much.